So let's make sense of the measurements we've taken. Okay, so we've got the Arduino board producing 4.65, say, before I said the 4.7, but let's say 4.65 volts of output to the circuit. That's a known. Okay, we've got the first component, which is the LED, and remember LEDs are directional, so we've got the positive end here shown by the inverted triangle filled in and the negative end shown by that line there. It's a light emitting diode, so therefore we have that arrow to indicate light coming out. And then we have the resistor, which I like to draw using a zigzag, and there it is. Now we know that this is a 100 ohm resistor. We know that the voltage drop across the resistor is 1.63 volts. We know the voltage drop across the LED is 2.98 or 3 volts thereabouts. And now we can compute or back calculate the ideal voltage for the LED light at the ideal current of 20 milliamps. Now remember, we measured the current was, conventional current everywhere in the circuit was 16.1 milliamps. Okay, so using Ohm's law now, I'm going to calculate the correct voltage for the LED at the ideal current of 20 milliamps. Okay, so just adding this. Alright, so let's draw the Ohm's law triangle again. V, I, and R. V for voltage, I for current, R for resistance, and all the units have to be in standard units. Therefore, current I equals 16.1 milliamps. Converting this into amps, right? Therefore, 16.1 divided by 1000 equals 0.0161 amps. Using Okay. Now let's prove that on the calculator. So, turning on, 16.1 divided by 1000, 1000 equals, there we are, the same number. Alright. The next step is to use my voltage across the LED as well as the current going across the or through the LED to work out the resistance of the LED. Once I know the LED's resistance, I can then back calculate the voltage, ideal voltage for the LED at 20 milliamps. Alright, let's do that. So the formula for resistance is I'll use my triangle again. I'll put my finger over the R for resistance. Therefore, resistance equals voltage divided by current, V over I. R equals V over I. Put the values into the equation now. So we've got 2.98 divided by 0.0161 equals 2.98 divided by 0.0161 equals, so let's just round it. So 185 ohms. Okay, next step is to use that resistance and the ideal current of 20 milliamps instead of this one here to work out the ideal voltage at 20 milliamps. Alright, so therefore to work out the voltage, I put my finger over V for voltage. V equals IR, or I multiplied by R. Right, so I just wrote down here optimum equals I R, and remember the optimum current is normally 20 milliamps. Put the values into the equation. 20 milliamps is 0.02 amps multiplied by 1, a bit hard to write with one hand, 1.8. Okay, so 0.02 multiplied by 185. Okay, and finally equaling, I'll just use that number, multiplied by 0.02, there it is, equals, right, so 3.7 volts. So I'll just round it, no need for that, all that precision there. You don't need 3.701863.2, just too precise. Let's just keep it 3.7. 3.7 watt, 3.7 volts. So that is the ideal voltage going across the LED at 20 milliamps. That means I need to have the right resistor. So I use originally a 100 ohm resistor. Okay, so that is obviously not the best resistor for this to get the optimum brightness. So therefore, the resistance to get optimal resistor, the resistance we want, we use Ohm's law again. So R equals V of I. So now remember, my Arduino board produces about 4.7 volts of power. Okay, and the ideal current draw is 20 milliamps. Therefore, I'm going to have 4.7 minus what's drawn by the LED, 3.7. 4.7 minus 3.7 divided by 20 milliamps, which is 0.02. I'm running out of space here. So, that's the formula so far. So, voltage output by the Arduino board minus the voltage used up by the LED. What we get left over in terms of voltage is the voltage used by the resistor. Okay, and then that resistance by the resistor, that voltage used by the resistor divided by the ideal current will give us the optimal resistance of the resistor. Okay, so now we simplify the equation down to 4.7 minus 3.7 is only 1, and divided by 0.02, which is the 20 milliamps, which is 0.02 amps, and let's do the equation and calculation. So therefore, reset 1 divided by 0.2 equals 50. So instead of using a 100 ohm resistor, I should be using a 50 ohm resistor. But by using a bigger resistor, more powerful resistor, more resistance resistor, I'm actually making the light dimmer but also prolonging the life of the LED. So not a big deal. I assume 3 volts for the LED. It should really be 3.7, but that's okay. It'll be fine. As long as the voltage drop is not too much, or not too little going across the LED will still work.